Hello everyone, now I'm going to talk about problem 2 for homework 10. From the lecture notes of the professor, we have to collect the definitions of properties of the stochastic processes and explain the understanding about these properties. First, we start with the wide-sense stationary process, or WSS. A stochastic process is called wide-sense stationary process, or WSS process, if the expected value is a constant and the autocorrelation is this. In another expression, we can list as this. WSS random processes only require that the first moment or the mean and the autocovariance do not vary with respect to time, and that the second moment is finite for all times. Any strictly stationary process which has a finite mean and covariance is also WSS. Second, the independent increment process. Xt is a process with independent increment if the probability of xta minus xtb less than x1, xtc minus xtd less than x2 equals to the probability of this. Times this. For any non-overlapping intervals, clearly independent increments implies uncorrelated increments. Poisson process, random walk, and the Wiener process are independent increment processes. 3. Markov process. A process Xc is a Markov process if the past has no influence on statistics of the future under the condition that the present is known, which means that this equals to this. T1 or larger than T2, larger than T3, and so on. This is the point. Okay, the fourth part, the normal process or Gaussian. A process Xc is said to be normal if the random variables xt1, xt2 to xtn are jointly normal for any n at any t1, t2 to tn, which means that this is where x is so this is small x. Five, the SSS. A real stochastic process Xt is stationary in strict sense or SSS if its statistics is not affected by a shift on the time axis. This means that two processes Xt and Xt plus epsilon have the same statistics for any epsilon. Which means that the value of fx_xt is independent of t. 6. The white noise. Vt is a zero-mean white noise if the autocovariance Vy, T1, T2 is Qt1 times delta T1 minus T2, where Qt1 is called the average intensity. White noise is the simplest example of a stationary process. It is a process such that its values at different times, xti and xtj, are nearly independent. Actually, they are uncorrelated. 7. The mean ergodic process. A stochastic process Xt is called ergodic if all its statistics can be determined from a single sample. In this region, any collection of random samples from a process must represent the average statistical properties of the entire region. Then Xt is said to be mean ergodic if when t goes to infinity, the interval from minus t to t of xt is over 2t is the expectation of xt in mean square sense, which states that ext equals to eta, which is a constant, and the limitation, and when t goes to infinity, the expectation of this is 0. Eight. Martingales. A discrete time martingale is a process x1, x2, x3, and so on that satisfies the expectation of xn is finite, and this. A martingale is a sequence of stochastic process for which, at a particular time, the conditional expectation of the next value in the sequence is equal to the present value, regardless of all prior values. That's all for this part. Thank you for your listening.